Hi everybody, today we're going to start learning about how to do calculations involving acids and bases and pH and all sorts of things like that. So obviously there's going to be a lot of math involved here. I'm going to walk you through the math, but by this point it's really important that you know the difference between an acid and a base, particularly the different definitions. So we had an older definition called the Arrhenius definition of acids and bases, and then we have a newer definition called the Bronsted definition, which is the one we use more often. Acids and bases all have to do with protons, this little thing called H+. It's got one proton in there, no electron, no neutron, it's just a proton. And in an acid-base reaction, these protons move around. Now, chemists are lazy. So really, when we put these protons in a solution, they latch on to a water molecule. So what would happen if I had H2O and then added to it this H+? Of course, it changes into this important little ion called hydronium ion. What I want you to know is that before we begin, although we should write H3O+, chemists are often lazy and they just write H+ instead. So when you see H+ and you know that it's in water, you can safely assume that it is really H3O+. So we use these things interchangeably. Let's get started. What is pH? So if you have a swimming pool, you might go out, I hope you do, and test the pH occasionally, because you need to be sure that the pH is something that's safe enough for people to swim in so that it doesn't sting too much in your eyes and things like that. Well, pH has a really easy definition. In fact, the little letter P, it means power of, power of. So what are we talking about the power of? We're talking about the power of hydrogen, H+. And anytime you see that little p, it means negative log of. The negative log of. Don't worry about that yet. I'll show you what that means in a minute. So pH would be the negative log of H. pH is the negative logarithm of the hydronium ion concentration in a solution. So of course hydronium ion is which one? H3O+, which we're lazy, so often we say H+. So I hope you see how P means negative log of and H means H+. So some pH calculations are really simple. If we know this number, the H+, then all we have to do is take the negative log of it to find the pH. There are going to be 6 equations which you will need to use for pH calculations. They start really easy. The first one is the one I just said. pH, the negative log of H, is exactly that, the negative log of H+ concentration, or if we want to be more accurate, we would write H3O+ concentration. Remember, when we have brackets, the brackets mean concentration of, specifically molarity of. So if we read this carefully, the pH, I would need to know the molarity of H3O+, and then I would take the log of that number, more on that in a minute, and then I would make it negative, and that gives me the pH. So it's really just as easy as typing it into your calculator. Now, here's where things get tricky with logs. What if I wanted to get this by itself? I can't just divide by negative log, because this negative log is operating on this H3O+. We're not multiplying anything here. And so, long story short, logs, of course, have to do with the power of 10. And the way to undo a log is by using that power of 10. So this is more a question of your math class. You don't need to understand why this works, but let's say I want to get H3O+ by itself. Here's what that equals. If I want to get H3O+ by itself, here's how it rearranges. 10 to the negative pH. So these equations are actually the same equation, just rearranged differently. I'd use the top equation if I want to find the pH. And I'd use the bottom equation if I know the pH and want to use that to find how much H3O plus I have. And don't worry, we're going to practice using these equations in just a couple of minutes. And also don't worry, you don't need to memorize them. They will be given to you when you have a quiz or a test. So all you need to learn how to do is use these equations. Now, can you take a wild guess as what POH equals? Hopefully that's something you might be able to do from memory. What is POH going to equal? Write it down. Well, remember that P, the little p, means negative log of. It's a shortcut. So when I write POH, what are we going to need to take the negative log of this time? The OH minus concentration. So just like pH was the negative log of H3O plus, or H plus, POH is the negative log of OH minus. Can you figure out how to get OH minus by itself? It's going to be exactly the same pattern as up here. So if I wanted the OH minus, I would take to 10 to the negative what? POH. Now, pH is not the same as POH, so I want you to remember that. pH and POH are very, very different, and I'll show you why that is soon. So now we have 4 equations that will help us convert between pH and H3O plus. We also have equations that will help us convert between OH and POH. But what if I need to convert between pH and POH? Are they related? I know that they're not the same. The next equation is kind of long and weird, but it can get you out of a pinch, so you'll want to remember it. It turns out if I take my H plus and multiply it by my OH minus, I always get the same number. If I take the H3O plus and I multiply it by the OH minus, I always get this weird number, 1 times 10 to the negative 14. Now when I say always, technically this only works at 25 degrees Celsius. At a different temperature it'll be slightly different. But anywho, we're not going to worry about that in this class. If I take H3O plus and multiply it by OH minus, I get this number, 1 times 10 to the negative 14. Why would this equation be really useful? That equation would be great if you have one of them, like H3O plus, and you need to know the other, like OH minus. You just plug in and rearrange. Or you can rearrange and plug in. Now, I know that that is the most confusing equation on here, so let me make it up to you with a nice simple equation. You'll like this one. pH plus POH equals 14. So if I know the pH, I can find the POH, because I know those numbers always add up to equal 14. If I know the POH, I can work backwards and find the pH. So remember these equations as you do your pH problems. Here we go. What's the difference between pH and POH? Well, first let's look at the pH scale. And I think that you're familiar with it. A pH of 7 means it's neutral. Now, which numbers would you like better? Would you like to use these weird numbers with the powers that are very large or very small? Or would you prefer to use these nice round numbers? So this is exactly why we use the pH scale. We get nice even numbers. This is called a logarithmic scale. So every time we move from one number to the next, what's actually changing with our H plus? Every time we move from one number to the next, the H plus either goes up by 10 or it goes down by 10. So the pH scale is a really easy way to say really huge numbers and really small numbers by using nice and even numbers. And of course we know if it's 7, it's neutral. If it's less than 7, it's acidic. If the pH is less than 7, it's acidic. And if the pH is greater than 7, it's basic. But what about POH? If I were to put POH down here on the bottom, how would that need to look different? Well, we had a really important equation, pH plus POH equals 14. So we can easily figure this one out. If the pH is 7, then what is the POH got to be? So in that case, the POH also has to be 7. But what if the pH is just 6? If the pH is 6, then what does the POH have to be? 8, because that's the only way that they can add up to 14. So let me fill in these numbers for you really quickly. So is the POH scale the same as the pH scale? No. So be really careful. A lot of people will say, oh, the POH is less than 7, therefore it's an acid, because acids are less than 7, and that's wrong. Actually, if the POH is less than 7, that must mean the pH is greater than 7. So if the POH is less than 7, we're talking about a base. Here's my recommendation. If the problem gives you a POH, what should you turn it into to make sure whether it's an acid or a base? Turn the POH into a pH. And there, everybody's comfortable with less than 7 pH is an acid, greater than 7 pH is a base. Here we go. What is the pH of a solution of HCl that has a hydronium ion concentration of 0.01 molar? What is the pH? All right, let's underline what it's asking for. What is the pH? Let's find out what it tells us. Hydronium ion concentration of 0.1 molar. What does that mean? H3O plus hydronium ion. The concentration is 0.01 molar. Okay, so it's asking us for the pH, and it tells us this, the H3O plus is 0.01 molar. Is there any equation that you can see on your sheet that will let us figure this one out? It's the classic pH equation, which you should write down. pH equals negative log of H plus. I got a little ahead of myself there. pH equals negative log of H3O plus concentration. Now, are we ready to figure out the pH? Sure, we absolutely can, because in order to know the pH, we need to know the H3O plus, and we already know that H3O plus is 0.01. So it seems to me that the pH would be the negative log of 0.01. And with a graphing calculator, it's really easy to do this, because we're going to see, sorry, my thing's all over the place here. We're going to see that the negative log, we just type in negative. Be sure not to use the minus sign. We're going to use the negative sign. Negative log of 0.01 gives us 2. And so, to go back to this slide, the pH of this solution is going to be the negative log of 0.01. The pH is 2. So, tell me about that solution. Is it acidic or basic? It's definitely acidic because the pH is less than 7. So it's acidic. How acidic is it? Well, drinking that would be like drinking lemon juice, because we see that lemon juice has a pH of 2. So it's very, very acidic. Remember, every time the pH scale changes by 1, it's becoming 10 times more acidic or 10 times less acidic. Or you could say 10 times more basic or 10 times less basic. So lemon juice is how many times more acidic than, say, wine? So each time we move is actually 10 times more acidic. So a pH of 3 is 10 times more acidic than a pH of 4. And a pH of 2 is 10 times more acidic than a pH of 3. So how many times more acidic is lemon juice than wine? It's not 20 times, it's 100 times. Wow, because that's 10 times 10. So now let's try a slightly harder calculation. A solution of acetic acid has a pH of 5.86. What is the hydronium ion concentration? Okay, so acetic acid, well, that's the same thing that vinegar is. Vinegar is just dilute acetic acid, about 5%. But we know that it has a pH of 5.86. So our question is, how much hydronium ion, H3O+, is in that vinegar? What is the concentration? Remember, brackets, anything inside the brackets means concentration of. So we want to know, what this question is really asking is, what is the H3O+ concentration? And of course, we know that the pH is 5.86. So ask yourself, do you know an equation that has both of these things? I'd like you to go ahead and write the correct equation down. There are two that could work, but one of them is solved for you already. So right, the equation we need to use is this one. H3O+ equals 10 to the negative pH. And this is very, very easy because that will be equal to 10 to the negative 5.86. And when we type that into our calculator, we type it exactly like we see it, 10, and then we'll hit the little caret arrow button, and then type the negative sign, 5.86. And my calculator gives me a really long number. It's actually a really small number. Don't worry too much about sig figs with these. 3 sig figs is usually going to be okay. 1.38 times 10 to the negative 6. Now, what unit would we need to use? Well, since it's a concentration, we're going to use molar. So 1.38 times 10 to the negative 6 molar would be the hydronium ion concentration. Any idea how we could check our answer? Well, if we know that that is equal to H3O+, how can we turn that back into a pH? If we took the negative log of this number, shouldn't we get this pH again? Because pH is negative log of H3O+. So let's try it. Let's make sure that we did this correctly. When I type negative log of 1.38 times 10 to the negative 6, I get 5.86 again. So that tells me that I did this correctly. Let's try one last problem. And these are the trickiest type. I'm actually going to show you two ways of doing this last problem. The first way is the first way is maybe more straightforward, but it's a little harder. So let's take a look. What is the pH of a solution of ammonia? That's what's in Windex to clean glass. What's the pH of the solution if the OH minus is 1.5 times 10 to the negative 3 molar? So this is really easy. I know that pH is negative log of H plus, and so here's my number, and so I just take the negative log of 1.50 times 10 to the negative 3, and what do I get? A wrong answer. So it's a really common mistake. Can you figure out what I just did? I see it all the time. pH equals negative log of 1.50 times 10 to the negative 3. We just assume that the number the problem gives us is the one we need to use. Is that the case? No, because this 1.50 is actually the OH minus. So what we just found is the POH, but it asks for the pH. What do I need to know in order to find the pH? In order to find the pH, I have to know H. So the first step to this problem, I'm not ready to do this pH part yet. The first step to this problem is actually finding the H plus. So this is a little tricky. I need to find an equation that relates H plus and OH minus. Which equation is it? Well, H plus times OH minus always gives us the same number, 1.00 times 10 to the negative 14. I know what you're thinking, or maybe you forgot. Wait a minute, mine says H3O plus. Remember, we can use H3O plus instead of H plus and vice versa. So H plus times OH minus gives us this number, 1 times 10 to the negative 14. Now I know that my OH is this, so I'm going to solve first, then plug in. Let's get H plus by itself. How do I get H plus by itself? So H plus should be 1.00 times 10 to the negative 14 over OH minus. Because I divided both sides by OH minus to get H plus by itself. So now let's plug in. 1.00 times 10 to the negative 14. I'm going to divide that by my OH minus concentration, which is 1.50 times 10 to the negative 3. And I got to type this in really carefully here. 1 times 10 to the negative 14 over 1.5 times 10 to the negative 3 gives us 6.67 times 10 to the negative 12 molar. So that's my H plus concentration. So it gave me my OH minus, and I used that to find my H plus. Now what can I do with that H plus? Well, let's go back to the problem, and it was asking, what is the pH? Am I ready to find the pH now? Sure. So pH is negative log of H plus. And I know what that H plus is, so this will be negative log of this number, 6.67 times 10 to the negative 12. And when I do that, I get 11.18 or so. So is that an acid or a base? Well, since the pH is higher than 7, it's a base, which makes sense because we're talking about ammonia. Ammonia is a base. Remember, acids have hydrogen in the front, so we know it's not an acid. Is there another way to do this problem? Is there a shortcut? So a lot of people don't like this equation because it's messy. It involves really messy numbers and lots of decimal places and everything. So can you think of another idea, another way to solve this using this really nice equation? pH plus POH equals 14. Well, the only thing we have is the OH minus. What could we do? Well, what if we turn this OH minus into a POH first? How could we turn OH minus into POH? Well, remember that P just means negative log of. So if I want to know the POH, I need the negative log of OH, which we have. So the negative log of OH is going to be the negative log of 1.50 times 10 to the negative 3. So when I take the negative log of 1.5 times 10 to the negative 3, I get 2.82. All done. Not quite. You have to be really careful about the difference between pH and POH. This question is asking what is the pH. But if you gave this as your final answer, you just gave the POH. So I turned my OH into the POH. Now, what do I need to do to find the pH? Well, if pH plus POH equals 14, let's solve that and get pH by itself. pH would be 14 minus POH. And we just found the POH. So 14 minus 2.82 gives me 11.18. So our answers agree with each other. We were able to get the same answer using two different ways. Which way do you like better? A lot of people like this equation down here, pH plus POH equals 14. But if you like, you're welcome to use this equation, H plus times OH minus gives us 10 to the negative 14. So I've made a little bit of a flow chart to help you decide which equation to use. Let's take a look at this real quick. So the first one is this one up here, pH to H3O plus. Let's say you have H3O plus and you want to find pH. Well, of course, there's two equations that relate pH and H3O plus. If you want to find your pH, you can use this equation. We just take the negative log of our H3O plus. Now, if you need to go backwards from pH to H3O plus, you use this equation. H3O plus equals 10 to the negative pH. The same thing goes over here. Find what we have and where we're going. Let's say they give you OH and they ask you for POH. You're just going to take the negative log of the OH. Or to get backwards, you're going to take the POH, go 10 to the negative POH, and get your OH again. But a two-step problem is going to give you, say, I don't know, here, this is the last problem. It gave us the OH, and what did it ask for? It asked for the pH. So the first way we did it is we went here. How do we turn our OH into our H3O plus? The first way we did it is by using this equation. H3O plus times OH minus equals 10 to the negative 14, and that got us our H3O plus. And then we were able to go from H3O plus to pH using this equation here. So that's one way of doing it, but there's a completely different way of doing it, which gives you the same answer. To get from here to here, first we could have turned our OH minus into a POH using negative log of OH minus using this equation. And then once we have our POH, converting between pH and POH is really easy using this equation up here. So this little flowchart, if you get stuck on a pH problem, can help you figure out where you are and where you need to be. If it gives you POH and asks for H3O plus, you can figure out which way to go. You've got two options. If it gives you something like pH and asks you for H3O plus, you've really only got one way you want to go. It's one of those. Otherwise, you'd have to go a really roundabout way of getting the right answer. Okay, just a couple examples of strong acids and strong bases. Remember that a strong acid ionizes completely. It breaks apart completely. HCl is hydrochloric. That's the acid that's in your stomach that helps break down food. HNO3 is nitric acid, really nasty stuff. H2SO4 is sulfuric acid, that's in your car battery. So those are all strong acids, meaning they break apart completely. And I put these in red and bold because those are three acids that North Carolina wants you to know on your state test at the end of the year. Now, weak acids break apart partially. In water. The fancy word for break apart is called ionize. So strong acids will completely ionize, they'll completely split apart, but weak acids will only somewhat split apart. The only weak acid you need to know is acetic acid. Remember, that's vinegar. We could write it two different ways, HC2H3O2, or this one, CH3COOH. We've also got some strong bases and weak bases. A strong base breaks apart completely in water. Two of them are sodium hydroxide and calcium hydroxide. And then a weak base does not break apart completely. It only breaks apart partially, and that would be ammonia. When I say for the weak bases, they don't break apart. Instead, they accept a proton. NH3 takes a proton and turns into NH4+. But does it steal all the protons or just some of the protons? It's a weak base, so it only can steal some of them. So I hope that you feel okay about pH calculations. We're going to be practicing this a lot in class. If you don't feel so good about it, I really do recommend that you go back and watch the three examples and how we use the equations to turn from one thing to another thing that we needed to calculate.